Okay, this one here might be a little hard to understand. It says, which of the following functions satisfies the kth derivative would be equal to 0, where k is greater than or equal to 6? So really, we're looking at these functions and we're wondering what happens when you start to differentiate them, where you hit 6 or more. So I'm going to look at the first one, and I'm going to say that does not go to 0. And the number one reason for that is this guy here, the derivative of this guy over here, it gets more negative. What do I mean by that? The exponent gets more negative. So you'd have -2, -3, -4, -5. So this one's not hitting that description. It's not going to go to 0. Now, if I look at, the x cubed one, and I said f of x equals x cubed minus 3, I also have to realize that, the first derivative would be x squared. The second derivative would be x cubed. I'm sorry. I didn't mean to say that. Let me start at the beginning. So if this is the function, what happens, the derivative of the first one would be x squared. Second derivative would be x. The third derivative would be 1. And I think you realize after that would be 0. So, first, second, third, fourth. By the fourth derivative, it's 0. So this one definitely fits the description that by the time you get the sixth derivative, it's definitely 0. All right? Now, I'm going to look at the other one and just talk about it. It's really f of x equals x to the 1/2 power. And I hope you realize here's another one, where I'm looking at the derivatives of this thing over here. The next one, I'm not even looking at the coefficient of it, but it's going to be -1/2. And then the next one's going to be x to the minus, well, you take 1 from that, -3/2. It just gets, the exponent gets more and more negative. So that one doesn't fit the description of going towards 0. So I'm going to say that doesn't fit the description. Now let's do this one. A little tricky, this one, isn't it? So this one is f of x, and that's going to be 5 minus x to the 6. By the way, I'm not worried about the numerical coefficient. I'm worried about the exponent now. The first derivative would be x5. Second derivative would be x4. The third derivative would be x3. Let's see. First, second, third, fourth, fifth. That would be a 1. And the sixth would be a 1. That doesn't go to 0. So I'm going to say 0. Maybe if I said seventh derivative would be 0. But right now, that doesn't fit the description. All right, let's keep going. I'm not going to say that fits the description, but let's keep moving. Look at when they're going to be 0. X to the 9 fifths, pretty obvious. That's not going to happen. What do? You keep reducing the exponent by 1. So it's going to be 4 fifths. The next one, I'm just thinking about what they do. You take, 5 fifths from -1 fifth. And I hope you realize the exponents are just getting more and more negative. That's not going to go to 0. All right, let's keep moving it. And I got this last guy over here. And the last guy, we just did the 6th power, but let's go through it. It's 8x squared plus 6x5. Let me repeat this. I'm not concerned about the coefficients. I'm just going to say this would be x, first derivative. Then it would be 1. That would go to 0 pretty quickly. So I'm not really worried about the first term. It's the second term I'm worried about. What do I get over here? This would be x4. Again, I'm not worried about the coefficient. First derivative, x cubed. Second derivative, x squared. Third derivative, x to the first power. Again, 1, 2, 3, 4. And then I get to the fifth derivative, would be 1. Time you get to the sixth derivative, you're at 0. So this one fits the description right over here. So there's 2 of them that fit that. Look in the blue area, make sure they said that. Solution, it said that this one fits the description and this one. Only these 2 fit that description. Thank you.